Welcome to the final section of the Rheology course. This section involves the examination of the rheology of multiphase materials. As before, I'd like to briefly chat about why the study of the rheology of multiphase materials is important. I would like to give some examples of typical multiphase materials with interesting rheological responses that you'll be familiar with, and then I'd like to give an outline of the next 4 lectures. So, up until this point, we have studied viscoelastic materials, viscoplastic materials, and generalized Newtonian materials. At no point, however, have we made specific reference to whether they are single phase or multiphase. When we studied viscoelastic liquids, we acknowledged that there are polymers present, sometimes in solution, but we never specifically looked at whether different phases exist, and if they did, whether they are important. Now, what we're going to do in this section of the course is to look how the structure of a product affects its rheological response, which affects its performance. And so we can think about the production of multiphase materials in the way that this cartoon shows. If we want to design, say for example, a new paint, what we might find is that we need many types of solid shape in the paint to give us our combination of shear thinning and viscoplasticity. And so what we're doing is we're tailoring the microstructure of a multiphase material to give us a certain set of product properties. And so we can get a formulation that works. We've also got to be very aware of how that structure can be changed through processing. As we know, if we're making a material, we're going to be subjecting it to deformation. And so does the deformation history of the production process affect the microstructure, which in turn affects the product properties? So, linking rheology to microstructure, to formulation, to processing is a very important task when we're dealing with these multiphase materials. Now, there are many multiphase materials that you will be familiar with. Back to ice cream. So, we mentioned ice cream when we were talking about viscoplasticity. We extruded a Mr. Whippy ice cream out of a Mr. Whippy machine. But ice cream in general is a multiphase material. It's a very good way of selling air very expensively. Air comprises a large part of ice cream, so we have a gas phase. We also have a sugar phase. We have a fat phase. And so there are at least 3 different phases present within a typical ice cream. If we consider cheese, cheese is effectively a fat protein matrix. And so again, we have a number of different distinct phases present within cheese, which gives us a certain rheological response. Let's think about everybody's favourite food, chocolate. Or maybe everybody's favourite food. Chocolate is an immensely complex material. There's a fat phase, cocoa butter. There's sugar present. There's sometimes milk solids, if you've got a milk chocolate, and there's cocoa solids. So we have a 4-phase material. Under certain conditions, the fat phase will be solid, and under other conditions, the fat phase will be liquid. And so we have a suspension of 3 different solids in a fatty liquid phase, which is itself not Newtonian. Finally, we have things like mayonnaise. Now, mayonnaise is a very good example of an emulsion where we have droplets of fat in a matrix liquid. And so we have, for example, fat in egg white, and that gives us the plastic properties that we see in a mayonnaise. And the shape of the mayonnaise in the bowl there is a very good example of that. So, the key point of putting this slide up is to show you that many common materials that you know about have complex rheologies, but those complex rheologies are driven by the fact that the material is itself multiphase in nature. So, what we're going to see in this part of this course are 3 lectures. The first lecture examines the concept of thixotropy, where viscosity varies as a function of shear rate and time. And we're going to introduce a model called the cross model to describe that. Lecture 15 looks at the rheology of suspensions. Now, suspensions are mixtures of solids in a liquid. And lecture 16 is going to examine emulsions, which is where you have 2 different immiscible liquid phases together. So, I hope you enjoy the remainder of this course, and thank you for watching.